Hello, this is Topolgin, and today we're going to talk about performance loss and how it affects our bottom line. And it's a concept that goes beyond overall equipment effectiveness because it includes more variables. And being aware of how it's affecting our profit, we can squeeze more out of our resources. Maybe even make a decision of buying new machinery, or we see opportunities in our manufacturing environment. Uh, so real quickly here, overall equipment effectiveness basically is a multiplication of three different um, measurements. The first one is availability, or a lot of people call it uptime. Is that machine running all the time that it's supposed to run, or it went down for some reason? Some unplanned maintenance, for example, needed oil, it was overheating, or a gear broke or something. So, in order to minimize unplanned maintenance, breakdowns of the machine, we need to get better at planned maintenance, which is preventive and even predictive maintenance. When we do those things, for example, on weekends or whenever that machine is not going to run, is scheduled to be down, then unplanned maintenance can be reduced. And we have to take into account uh, for how long that machine has been running, how old that machine is, how much it's costing us and all that. It might be good even to look at the new machine and justify it, if the volumes justify it, etc. So availability is basically uptime of the machine. Performance is determined first of all by the standards in our ERP system. For example, SAP has a standard of this many pieces per hour. That standard is usually set up between the bill of materials group and the cost accounting group. Also, manufacturing engineering has an input on that. And some of the calculators built in this are in order to help those two departments, basically. Well, those three departments. Manufacturing engineering builds them for bill of materials or for um, cost accounting. So we can um, bid the right price for our products the first time. A product that has never been built, well, this helps us do it. Or a product that is already being built, we need to uh, stay on top of our standards, our standard times. And so that's part number one. How good our standards reflect reality, and they have to include also personal fatigue and delay, or personal time, what it's called also. That personal time, I have another video where I talk about it on more depth, but basically what it is an operator on hour one is not going to give us the same output, the same performance as the same operator on hour 7 or 6 or 8. It's going to be a little bit tired. It's going to, need to go to the restroom, whatever. Personal fatigue and delay. So, how well those standards are, if we are not meeting the standards, and also if the standards are okay, well, how well production is pushing and coaching and whatever to adhere to those standards. If the operator is not meeting the standards, so he can get some overtime over the weekend, well, that's going to hurt our bottom line. So we need to deal with that. So performance is kind of a two component also uh, unit of measure, if you want to call it that way. Manufacturing engineering or whoever sets the standards in the system have to be as close as to accurate, as close to reality as possible. And also production has to adhere to those standards. So machine running, uptime, and then we're performing really well. That's good, but also quality, which is basically basically the good count versus the total count of parts. So if we build 1,000 but only 950 are good parts, then our quality is 95%. So that's kind of the definition of each part that goes into overall equipment effectiveness, sorry. Here we have availability, performance, and quality, those three things. Now, all the numbers in between column G, A, H, and I are randomly generated in between these two numbers. So I can say my minimum should be 92 and my maximum should be 96. So all of these numbers are generated in between those two. And our total multiplication of those three numbers is our overall equipment effectiveness. In this case, we say, well, 92 and 96 are not that bad. They're not that bad of a number. So we get 81, for example, for product one on process number one. But what happens if that product goes to a second process and a third process? Here we have our products 1 through 10, and here we have the results of each one of those processes in each one of those measures. Um, so we see here product 1 81%, 86% for second process, and 83%. So basically, what we're saying is out of process 1, this product is perfectly good 81% of the time. And then it goes into a second process where only 86% of what comes in, 86% of that 81 is going to be okay. And then we say if it goes through a third process, 83% of what comes in will come out right. So basically, we multiply all those three numbers here and we get about 58%. We started with numbers that didn't look too bad, not that bad. We ended up with number that is really bad. That that means that basically any any of these 10 products, our maximum would be about 60 and our minimum would be about 54. So anywhere between 54 and 60% overall equipment effectiveness we have here, which is really, really bad. World class is supposed to be around 85%. So that's the first tab. Second tab I want you to look at is this. Basically, we have OEE over here, availability, performance, and quality, but also we have sorry, work in progress tracking. And work in progress is basically if a product is going to go through department A and then department B or A and C or B and C or A, B, and C, we need to be tracking those parts and not lose them, etc. It doesn't matter if it's a high mix, low volume uh, manufacturing environment or a low mix, high volume manufacturing. It doesn't matter. It doesn't matter. If I build three, I should be able to find those three pieces. If I build 3,000, I should be able to find those 3,000 pieces and track them throughout the system so they are available for the next and the next and the next process or the next department. So we have our OEE here and we have our work in progress tracking, and we have three departments. And let's say this is just one product to simplify things. Basically similar to the example, except we are another variable, another uh, uh, key indicator. And when we multiply the four numbers, we get this number. If that part or that product goes only through this department, through this area, that would be our number, not a bad number. But what happens if it goes through AB? We get this number. Or through B and C, department B and C, we get this number when we multiply these two. Or A and C, we get this number. So that's when it goes through two departments. So the number goes low. right? Goes below 94%, goes all the way to 89, 91, 93, so it's getting lower. What happens if it goes through three areas? That that is actually not bad because our minimums and maximums are here, but are very, are really, it came down quite a bit from the original ones. I mean, our minimum is 98%, our maximum would be 99%. Let's say we put 92 and 96. This, by the way, in this channel, all the cells that are in green and the fonts are in yellow means user defined inputs. These are user defined inputs. These ones over here are user defined inputs, and that is because probably I'm gonna put out this for public download, and it's gonna be locked, so you can only change those two inputs, and it's gonna serve you as a visual reference of what I'm explaining, and maybe you can use it in your company, or for for whatever purposes you might need. So now, see, the numbers are not doesn't seem don't seem too bad. 92%, 96%, not too bad, right? But when you multiply all of them, let's say this product is going to go through those three departments or three processes or whatever it is, it's going to go down all the way to it could go down all the way to 42%. Wow, that's bad. That is a performance loss. So we can see immediately where we can start um, implementing initiatives and uh, maybe renew our equipment. There's several areas, maybe improve our maintenance and our maintenance tracking records. For example, uh, what is the oldest machine in that department? How much does it cost for a machine to run? What's the costliest machine to run in any given department? Can we save some money if we buy a new one? How manual or how automated are our machines or our processes? Can we substitute 4, 5, 7, 12 machines, very manual or close to manual, semi automatic, with a very, very automated machine? We're going to save on processing time, we're going to improve our quality, we're probably going to reduce our scrap because those new machines have technology built in, software built in for nesting, which means our scrap is going to go down. Any material, wood, metal, whatever. And we're probably going to save energy, maybe, because they are very efficient also in energy, and also footprint of our manufacturing environment, or of our manufacturing plant, because we're going to substitute several machines with that one. Now, do we have the volume to justify a new one? Do we have the return on investment set up by the owners or by the CEO of the company? If we have 1 year return on investment, well, that's too that's a big constraint. If we have 3 years return on investment, that sounds a little bit better. 5 years return on investment, not a lot of people do it, but there's some companies. Or are we gonna be like Amazon and Mr. Jeff Bezos, that goes all the way up to 7 and maybe sometimes 10 years, if he really wants to get into a new industry, a brand new industry, and he just want to take it by storm? Well, maybe a new product, maybe whatever. It depends on our return on investment, but it this analysis can help us make that decision. Should be part of that decision process for justifying any change, any improvement of machinery, of processes, uh, etc. So I hope this added value to you. Remember, top Olgin, and I'll see you on the next video. Thank you very much.